Hello everyone, this side is Ritik and today we are going to solve another most asked technical coding question which is mostly asked in the interviews round. So that question is prime number. We have to find the prime number in the JavaScript. I will give you two methods. Okay, first one is little bit tough, second one is easy as comparison to first one. So firstly I explain you what is the prime number. Okay, so prime numbers are natural number greater than 1 which are divisible by 1 and itself. Example include 2, 3, 5, 7, 11, 13, etc. Okay, one is neither a prime number nor a composite number. Okay, so in simple words, prime number is basically that number that is divisible by itself or by divisible by 1. Okay, so that is the prime number. Okay, so first we first we see the question, what in the question given, and then we will write the code. Okay, so the question is, write a JavaScript function named is prime that takes a single parameter nums and return true if the number is prime and false otherwise. Okay, the function should follow these rules. Okay, if the number is less than or equal to 1, it should return false. It should iterate from 2 up to the square root of the number, math dot square root num, and check if the number is divisible by any of these integers. Okay, if it is divisible by any number other than 1, okay, and itself, it should return false. Okay, if the number satisfy both condition, it should return true. Okay, use the function is prime to determine if the following number are prime. Okay, so here the time complexity is given. Function is O root n. The space complexity of the is prime function is O1. Okay, so we have this time complexity and space complexity. Now we have to write the code. So for this we have to create one function that named as is prime, and we have to pass one argument that is parameter. Okay, we have to pass one parameter that name num. Okay, it is given in the question. We have to create function named is prime and we have to pass a single parameter that is num. Okay, now we have to check for the condition if num less than equal to 1. Okay, so it should have to return the false. Okay, it should have to return the false, and again we go for the loop, that is for let I equal to 2, I less than equal to math dot square root num I plus plus. Okay, so the loop is going from I equal to 2 to I less than equal to math dot square root num. Okay, and it will be incremented by I plus plus. Okay, then we have to check the condition if num modulus I equal to 0, and that is the strictly equal to 0, it should return false. Okay, so this is the code. Now if both the condition is going to be true instead of false, so we have to return the true. Okay, now what we do, we have to print this by using the console dot log, and we pass one argument in the is prime function that is true. Then we have to find then we have to go for 7, then we have to go for 10, then we have to go for 17. Okay, and if we run the code, so we get the answer that is true, true, false, true. So B is true. Okay, so I will explain you the full code, how the code is work basically. So we create one function that named as is prime, and we pass one argument. No, that is a parameter. Okay, we pass one parameter here that named as num. So as I told you earlier that if num less than equal to 1 means 1 is not in prime number, as we know that 1 is not in prime number. So if num means negative integer is also not in prime number, so num less than equal to 1, so we have to return the false because this is not in prime number, that's why we return the false. Okay, so if this condition is not satisfied, and if this condition is also not satisfied, this condition then satisfy. Okay, so now we take one loop that is run from I equal to 2 to I less than equal to math dot square root num I plus plus. So the question is arises in the mind, why we take math dot square root function. So the reason is taking the math dot square root function, that is like just consider a natural number which is n, okay, that should be greater than equal to 1, okay, which exists as a product of two number a and b. Assume a less than equal to b, it should be greater than 1, not equal to, it should be greater than 1, okay. So like n equal to a into v, if we take n equal to a into v, where n, where 1, a is greater than 1 and it is less than equal to b and less than n, okay. So b less than n basically, okay. So by multiplying the relation a less than equal to b by a, the relation become a square less than a b, okay, less than equal to ab. Then by multiplying the relation a less than equal to b by b, the relation become ab less than equal to b square, okay. From the above mentioned inequalities, the relation become a square less than ab less than equal to b square. We know that n equal to a into b, so by replacing a into b with n, the following relation is obtained, that is a square less than equal to n less than equal to b square. So taking the square root of the equation, considering both a and b as positive number, we get a less than equal to square root n less than equal to b. So according to the above relation, it can be concluded that one of the factor of a non-prime number will definitely be less than or equal to the square root of n, okay, one of the factor, okay. So suppose uh, we take one non-prime number, that is 15, okay. So you can see here that one of the, okay, because the basically the factors are 3 and 5, okay, and if we take the root of this, we get something around 3.87, okay. So you can see that we just take the whole number of this, that will be give you the 3, and if you compare that, it is equal to the square root, and here 1 is also uh, the factor of the 15. So that's why we take math dot square root, and from the above relation you will understand why we take math dot square root, okay. So uh, by knowing this, okay, so if we know this, we actually get that this number is a prime number or not, okay. That's why we take mat dot square root here, okay. I think now you get it. Now we compare it, okay. If we compare it, it will equal to 0, so it automatically return the false, okay. So you understand that, okay. So now uh, now for example, if we take is prime number, that is prime is 2, okay, we take is num is 2, okay. So if we check for this condition, if we check this condition, this will not going to return the false, so definitely it will go there and it will return true, okay. Now you get this, okay. And for this, if we check it, if we take the square root of the 2, if you find the square root of the 2, you get 1.414, that is the square root of the 2. So obviously the loop is not going to run because it is started from 2, okay. Now if we take for 10, okay, 10, that is the basically the non-prime number. So for the 10, no 10 is greater than equal to 1, so 10 is less than equal to 1, no it's this condition is not satisfied basically. So like if we find the square root of 10, suppose we have to find the square root of 10, we get 3.16227, that is the square root of the 10. So the loop is run till 3, till 3 it is run till 3, okay. It is run till 3, and it is run till 3, okay. So like for that is num is 10, and if we go with 10 modulus 2, it will definitely give you the 0. Hence it will return directly the false, okay. So that's why it will give you the false, okay. For the rest of the number, you have to check by your own self. This is the homework, okay. Now we see the second method, okay. So for the second method, I just do the comment out, okay, and we have to write the second method, okay. Second second method. Okay, so we have to create one function that is named as prime. Okay, and we have to pass one parameter. Okay, we have to pass one parameter here, and we have to take one variable that is count, that is 0, and we have to run the loop for let I equal to 1, I less than equal to num I plus plus. Okay, now what we have to do here, if num modulus I is equal to 0, so what we have to return here, we have to increment the count. Okay, we have to increment the count, and if we increment the count, so what happen in this code, we take one parameter that is named as num. Okay, we take one parameter that is named as num. Now we take let count equal to 0. Okay, for let I equal to 1, we check from I equal to 1. Okay, because 0 doesn't make any sense. Okay, so for if it is divisible by 1 or by itself, means if it is like for example that is a 7. Okay, if it is divisible by 1, okay, it should be divisible by 1. Every number is divisible by 1, we know, so it will give us 0. Okay, and if it is divisible by itself, okay, so if it is divisible by itself, it should also give us a 0. So when we get a 0, okay, when we get a 0 by doing this, the count is automatically increases from 0 to 1. Okay, for like for 1, it if we take the modulus with 1 of any number, suppose it is 7, suppose we take 7 modulus 1 give you 0, so the count is increases from 0 to plus 1. And again the loop is iteratable. Okay, so it is going to run. Okay, so it is going to run till 6, and then it is going to run for 7. Okay, so for the 7, if we check 7 modulus 7, that is given give that is it give you the 0. If it is give you the 0, count value from 1 is incremented to 2. Okay, so for the 7 modulus 1, so will give you 0, so the count value is increased to 1. Okay, now if we take for 7 modulus 7, it will give us 0, so again the count value from 1 increases to 2. Okay, so like this the code is work basically. Okay, now what we have to do, we have to print a value of count. Okay, so we take like we have to print the value of the count. No, we don't have to print the value of count. Instead of that, we have to compare the count value with 2. Okay, so we are going to compare the value with 2. So if the count value is 2, it should return true. Instead of, we take console.log dot equal to, that is the prime number. Okay, it is the prime number. We take again console.log not an prime number. So what we do, we just increment the count, and the count value is compared with 2, because count, if it is equal to 2, then it is a prime number. Okay, now we run this. If we run this, we get nothing. Why we why we uh, why we not get anything? Because here we have to pass one argument, that is 2. If I pass 2 here, 2 is a prime number. If I pass 7 here, okay, if I pass 7 here, what it will give? It is also given prime number. 7 is also in prime number. But if we pass 10, it is not able to give a prime, because it is not in prime number. Okay, so for the 10, how the code is work for the 10? Okay, so we take the value of 10. Okay, we pass one parameter num, and in this we get a value of 10. Okay, Here we get a value of 10. So 10 is less than equal to num, I less than equal to num. 10, we have to compare it, I plus plus. If num modulus I, okay, 10 modulus 1, that will give you the 0. Definitely will give you the 0. Okay, so here we get 10 modulus 1, that will give you the 0. Okay, now count is increases by 1. Okay, count is increases by 1, so 0 plus 1 is equal to 1. Okay, now 10 modulus 2 we will take. Okay, because I now I for the second iteration I is 2. This is for the first iteration, and this is for the second iteration. Okay, so it will also return 0. Okay, this is for the second iteration. Now for the second iteration it is returning 0, so it should be a prime number. No, the loop is again run. Okay, now I is become 3. If we check for the 3, for the iteration 3, if we check, so if we check for the 3, we didn't get 0. Okay, if we check for a 4, we still didn't get any 0. Okay, for we check for the 5, we get a 0. Okay, for the 5, if we take 10 modulus 5, it will give you 0. Okay, so count value is increases by 3, and we get the condition if count equal to 2, then it should return prime number. Not it should return not in prime number, because we know the number is a natural number which is divisible by 1 or by itself is a prime number. I hope you understand what I am trying to explain you, and I hope you like my videos. For more such a content, please subscribe my channel. Okay, and please click the bell icon to get more updates. Uh, and we will see you in the next video. Okay.